Good morning. My name is Napurski. We're going to solve a Class B subnetting problem now. So we're going to work in the third octet for our scheme. This is a little more complicated because now we have 16 bits available to subnetwork. So we're going to solve for 12 subnets. So let's go ahead and get started with step 1, which is to represent 12 in binary. We will then invert or flip the result. And again, like we said, from the last bit borrowed going left, in order to make a contiguous subnet mask, we must turn on the high order bits. This potentially gets us our new subnet mask. So this is potentially our mask, 255, 255, 240.0. Step 3, let's go ahead and figure out how many subnets we're going to get. So we borrowed 4 bits. Two to the 4th minus 2. Gives us 14 subnets. How many bits did we not borrow? Now careful, don't get tripped up here. We did not borrow the 4 bits left over in the third block, nor have we borrowed the remaining 8 bits in the 4th octet. So it's going to be 4 plus 8 is going to give us 12. 2 to the 12th minus 2. Remember, we're throwing out the first and last subnet or the first and last address. $4,094 hosts per subnet. Anybody? I'm recording. So we have 4,094 hosts per subnet. Now let's go ahead and figure out the block size so we can show the range of address and the valid IDs. The block size equal to the lowest bit that we borrowed. That value is 16 in this case. So let's go ahead and show the valid range of networks. In the octet which you were working, which in our case is the 3rd, start adding the block size and continue to do so until you reach 240. Okay, again, we're going to throw out the first and last network ID, and then we'll count them up. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Said I'd get 14. Okay, we can go back and do another check. We borrowed 16 bits with the default mask, plus 4 bits and 12 bits is 32, so we have 32-bit scheme. So far we're looking really good to solve this problem. Let's now go ahead and show the valid range of addresses for the 96 network. Hang on while I move the camera. Again, first step here to show the actual new subnet mask, and we're going to convert to binary. So I'm going to get right mask there. Now I'm going to show the 96 network ID. Remember, we're masking a portion of this address. In this case, it's from here over. Okay? The first 20 bits. I want to draw this in prefix. /20. We'll do a little prefix primer later. So let's go ahead and draw the minimum host ID for the 96 network. Okay, the lowest available bit is 1, so we're going to turn that on. Then the maximum address is all host bits turned on except for 1, all available host bits. And then the broadcast. Now we're not going to go ahead and show the 4,000 hosts per subnet, but as you can see here, if these are your available bits, or this is your network ID, minimum address, maximum address, and broadcast, notice the maximum is all available host bits. I had 12 bits available, so the maximum address is 11 bits turned on. And that solves our problem.